Hello class, in this video I will be introducing exponential functions. Let's begin. An exponential function is a function of the form f of x is equal to b raised to the x power. X can be any real number, b must be strictly greater than 0, and b must not equal 1. b is called the base of the exponential function. Exponential functions in this form have certain characteristics. The domain is all real numbers. The range is the open interval from 0 to infinity. Exponential functions of this form have a horizontal asymptote at y is equal to 0. There is no horizontal intercept, and the vertical intercept is 0, 1. And that is because if we evaluate the function at 0, b of 0 is equal to 1. There's a special base called the natural base. It is an irrational number represented by the letter e and is approximately 2.71828. So now let's take a look at a couple of examples on how to graph an exponential function. Sketch the graph of the exponential function f of x is equal to 3/4 raised to the x power. From the properties discussed earlier, there is a horizontal asymptote at y is equal to 0. The graph of f of x has a vertical intercept at 0, 1. To graph this function, I'm going to find a few more points on the graph. So I'm going to evaluate this function for when x is equal to -3. This is equal to 3/4 raised to the -3 power, which is 4/3 to the third power, which is 64/27, which is approximately 2.37. So I'm going to plot the point -3, 64/27, which is about right here. Next, I'm going to evaluate f of -2. This is 3/4 to the -2 power, which is 4/3 to the +2 power, which is 16/9, and this is approximately 1.78. So now I'm going to plot the point -2, 16/9. So we have -2 and 16/9 is about right here. F of -1 is 3/4 to the -1 power, which is 4/3 to the first power, which is approximately 1.33. So I'm going to plot the point -1, 4/3, which is about right here. And finally, I'm going to evaluate this function for when x is equal to 1. This is 3/4 to the first power, which is 3/4, which is equal to 0.75. So I'm going to plot the point 1, 3/4. And that point is about right here. So the graph of f of x is going to look like this. On to example number 2. Sketch the graph of the exponential function f of x is equal to -2 times e raised to the x power. From the properties discussed earlier, this function is going to have a horizontal asymptote along the line y is equal to 0. I cannot place a vertical intercept at 0, 1 because e raised to the x power is being multiplied by -2. So to determine the vertical intercept, I'm going to evaluate f of 0. So that would be -2 times e to the 0 power, which is -2 times 1, which is equal to -2. So the vertical intercept is 0, -2. Now I'm going to find a few more coordinates on the graph of f of x. F of -2 is equal to -2 e to the -2 power, which is equal to -2 divided by e squared, which is approximately -0.26. 7. So I'm going to plot the point -2, comma, -2 divided by e squared. And that's going to be about right here. Now I'm going to evaluate f of -1. That is going to be -2 times e to the -1 power, which is -2 divided by e, which is approximately -0.74. So I'm going to graph the point -2, comma, -2 divided by e, which will be about right there. And finally, I'm going to evaluate f of 1, and that's going to be -2 e to the first power, which is approximately -5.44. And I'm going to plot the point 1, comma, -2 e to the first power. And that would be about right there. So the graph of f of x is going to look like this. And we are done.